Hello everyone, welcome to another tutorial of SlideScope. In this tutorial we are learning about Anscombe Quartet Dataset. But first, and we'll be doing it with the help of Tableau. We'll explore it, analyze it, print the values. But before that we have to understand what is this Anscombe dataset. So it comprises of 4 data sets that have nearly identical simple descriptive statistics, yet they have different distributions and appear very different when graphed. Each data set consists of 11 X5 points, and they were constructed in 1973 by the statistician Francis Anscombe to demonstrate both the importance of graphing data when analyzing it and the effect of outliers and the influential observations on statistical properties. He described the article as being intended to counter the impression among statisticians that numerical calculations are exact but graphs are rough. What it means is, so we have x and y values. As you can see in the data set, we have x and y values. Let's see the data set here. So let's open Tableau and first let's see the data set. Here we have 4 data sets, 1, 2, 3 and 4. We have labeled the data sets as 1, 2, 3 and 4. 1, 2, 3 and 4 have x and y values. Okay. Now when we apply linear regression in these 4 data sets, you can see the outcome. Okay. You can see how different the outcome is. But the interesting thing here is mean of x in all the cases is always 9, sample variance of x is 11, mean of y is always 7.5, sample variance of y is 4.125, correlation between x and y in cases is 0.816, and a linear regression line is this. Now let's see how we can do the same thing, how we can build the same dashboard in Tableau. So first we will load the data set. I'm also doing it for the first time. So let's see. Now we'll name it as data set 1. Let's say data set 1. Now in data set 1, as you can see, we have x and y values. We'll use simple filters. So first we will put x on columns and y on rows. What it will do is, it is not building these scatter points for us, as you can see here. This is because by default in Tableau the aggregate measures are on. So now we have this. Now why are we seeing so many points here? Because in our case that we are seeing this for 4 different data sets. Let's visualize, right? So here you can see every blue dot is representing, let's reduce the size of the, every blue dot is representing data set 1, orange 2, red 3 and this 4. So what we have to do is, first if we want to build 4 different visuals, so to build 4 different visuals we have to create 4 different sheets, and instead of dragging it in color, I will drag it to filter, and in the first sheet I will simply select dataset 1. So we have the dataset 1. Now let's duplicate. So now you can see we have 4 different sheets here. We'll rename them DS2, DS3 and DS4. Okay, and what we are going to do is in DS2 we'll edit the filter and select only 2, apply, okay. I can also show the filter and do it, but let's do it this way. Here I'll select 3, apply, okay, and 4, apply. This is 2, 1, 2. I'm pausing and doing it. So 4. So now you can see we have 4 different data sets, 1, 2, 3 and 4. Okay, as it is mentioned in the paper that in all the cases you can see here the data is distributed like this, here the data is distributed like this, here you can see it is almost on the line but there is one outlier. Here we have only one value of x but just one different value of all the other values are similar but just one value is different. So it is showing the effect of outliers on the outcome, and that's why it is said that the article is being intended to counter the impressions among statisticians that numerical calculations are exact but graphs are rough. Okay, so as you can see mean of x y all are same. So now in this case we have done this. Let's say what is mean of x in this case, right? So we'll drag x here, and instead of this we will just do, instead of sum I will do, average. Let's do average. So you can see average of x is 9 in all the cases, and if I drag the data set to filter, apply it, okay, and show the filter. If I select filter number 1, mean is 9, filter number 2, mean is 9, 3, mean is 9. If I select 3 and 4, mean is 9. So this is what it is showing, right? You can also choose a different measure. For example, you can select standard deviation. So it is 3.3, it is 3.317. So this is how interestingly this data set has been constructed. Whether you select one data set, all data sets, you will see that these values are same, and same for the case of y also. We just tried with x. So that's what it is written here, like mean of this, mean of y. This is something that you can do on your own. Where is Tableau? Sorry. Now, now we have this, and we'll just delete this. Now what we are going to do, we'll apply linear regression here. How you can apply linear regression and check for, we have to check for y is equal to mx plus b, the regression line. Okay, so just go to analytics tab, and from here just import trend line and linear trend line. Okay, you will see a line. So now you can see we are seeing this, right, this one, and see the equation of line y is equal to, just read here, right, y is equal to 0.50091 x plus 3.00. This is y is equal to mx plus b. R square, which is the accuracy, it is 0.66 or 66% here. Let's go here and drag the trend line. Okay, so here also we are seeing almost the same data, right? 0.5x plus 3. 3 is the point where this line will touch the y-axis. So this is the intercept, and 0.5 is the coefficient or the slope. You will see the same data here, and you will see the same data here. So that's why by just seeing the graph, by just comparing, by just describing the data, we cannot say how it is going to perform. But we have to, visualize it numerically, as well as means we have to do the numerical calculations, but we have to visualize it also. That's what we want to do, because in all the 4 cases you can see what different visualizations we have, but we have the, the calculations are same. So this is what this data set is all about, and I'm just doing some cosmetic work here. Okay, so this is what it is written here, and this is what we have visualized. The first scatter plot appears to be a simple linear relationship corresponding to two correlated variables where y could be modeled as Gaussian with mean linearly dependent on x. For the second graph, while the relationship between our two variables is obvious, but it is not linear. It is not linear, and the Pearson correlation constant is not relevant. In the third graph, the model relationship is linear. As you can see, it is linear, but we have a, you know but we should have a different regression line. A robust regression would have been called for. The calculated regression is offset by one outlier, which exerts enough influence to lower the correlation coefficient from 1 to 0.816. So this is what we are calculating. We can create a simple dashboard also to show all of them on a same plane. Let's say the minimum height is 850. The minimum height we are keeping 600 and width we are keeping 800. Let's do 900. Yeah. And now we have these DS1, 2, 3, 4. We can just drag them 2, 3, and 4. And you can display more data here, but this is the demonstration that we are doing. This is the calculations that we are doing, and just copying the same graph, learning how to do it in Tableau, how to get these values in Tableau without calculating them, just visualizing them. So I hope you learned about this Anscombe dataset, and if you like this tutorial, please subscribe to our channel, because we will be posting more videos related to Tableau. I also have a Tableau tutorial for absolute beginners on my Udemy profile. It is currently at a discounted rate, so you can go and buy this. We have detailed tutorials here, installing, creating different type of charts, connecting to different formats of data, connecting with MySQL, PostgreSQL, Excel files, CSV, JSON, and whatnot. Applying regression, clustering, forecasting on different type of data sets. We have some previews available also, which you can see. So it is obviously optional. So have a great day. Build this dashboard. If you have any problem, please share with us.